Now, hooks are quite fun as well. They're essentially the system for enforcing security and compliance policies automatically throughout the development workflow. They're essentially automated checkpoints where you inject custom logic into Cline's workflow. Think of them as similar to Git hooks, but for AI operations. We have a few in particular that I find myself using often, such as PreToolUse hook, which runs before Cline executes tools like file editing or command execution. It's perfect for validating that an operation doesn't violate security policies. Now, PostToolUse hooks run after operations complete, which is great for auditing changes and building compliance trails. UserPromptSubmit specifically screens user input for policy violations or sensitive data exposure. At least I find that that's when it's best applied. And TaskStart and TaskComplete hooks track the entire task lifecycle. The power is that hooks receive detailed JSON input about their operation and can execute arbitrary logic, including calling external systems, and they can even block operations before they cause issues. They can also inject context that guides future AI decisions within all of this. Now, you might be wondering how hooks work. Well, hooks are executable scripts that receive JSON via standard in and return JSON via standard out. When an event triggers, say Cline is about to edit a file, the PreToolUse hook receives detailed information, such as the tool name, the file path, the operation details, and of course the workspace content. And your hook logic executes, and this could be a bash script that checks file extensions, a Python script that scans for secrets, or even a call to your external security scanning API, if that's something that your organization prefers to utilize. Now, the hook returns a JSON response with three main fields, either cancel, which is true when it's going to be blocking the operation, context modification, which includes guidance injected into the AI's context for future decisions, and error message, which is usually an explanation if there's a blocker happening. And if you return cancel equals true, the operation halts immediately. Hooks really have two main places that they live. They either live globally in your documents folder, or they live in your project under Cline rules/hooks. The great part about this is that project hooks can be version controlled and shared across your team. So without further ado, let's hop into yet another demonstration. The main key to this demo is that we will be going through and of course, taking a look to see. Let's demonstrate a PreToolUse hook. Specifically, we should see if there are any secrets before there are file write operations. So it's kind of like what we were looking at earlier with our good config and our bad config more than anything else. Let me go ahead and share my screen again, and we can take a look at specifically where we would configure hooks. Hooks usually are configured within Cline itself, and there are rules and workflows that we have here. It looks like I need to make a minor adjustment to enable hooks, which I could have sworn was enabled, but I just got a new machine. So I'm going to go ahead and enable hooks, enable skills, which shouldn't be needed in the latest versions. So now that we have that, let's go ahead and take a look at the configurations. So now we have hooks available here. We have global hooks where we can create a new global hook within the documents folder. I should call out that that doesn't fall under source control of the repository that you're working on. So I find those are more good for experimentation as well as creating your own custom rule sets. Now, if you want it to be scoped to the repository, let us just create the hook here. You do need to toggle it on, and we can just go ahead and create this hook together. Why don't we? So let's say, let's add a hook under and Cline rules/hooks /PreToolUse. This should for I'm not talented enough to talk and type at the same time, apparently. But yes, this should check for security vulnerabilities. Let's keep it very simple for this demonstration. So right now we have Cline working through. We are creating a new security vulnerability checking hook for the PreToolUse space. We already do have an existing secret detection hook, which I can briefly show you guys as well, such as here. So this is the PostToolUse example that we have. This effectively shows that we will be returning false. The context modification is the PostToolUse response. And before I even got done with that sentence, Cline is already done with creating the new hook for our use case. Let us take a look, and before we accept it, we can take a look at the content as well. We're essentially going to be looking at the JSON input. We are going to be extracting the tool name and parameters, and we have some general security vulnerability patterns that we will be detecting. So that is a general approach here. That looks great to me. And we can go ahead and make it executable, which thankfully Cline is being kind and doing that for us. What a great co-pilot, I gotta say. Sweet. And it'll create a small demonstration as well. Let's test this hook. Now, because of some of the vulnerabilities that we were intentionally adding in, such as these hard-coded credentials here, we have an intentionally vulnerable file that we are going to be passing in. Specifically, there is a vulnerability for command injection. There's a SQL injection. Oh, perfect. We can see, sorry, I keep interrupting myself. I'm getting excited. So within this, we can see that cancel was true because there is a security vulnerability detected, several to be specific. So we blocked this operation to prevent security risks. And we even have some recommended actions here. The context modification is that the previous file write was blocked due to security vulnerabilities. All code must follow secure coding practices within this. So we're just doing a little bit more adjustment here to make sure that we are catching everything necessary. And there's also just a minor syntax error that it's being very kind and fixing for us as well. I think that honestly sold the point. So that was effectively the hooks in action. It'll continue working in the background just to tidy up some of those syntax issues. But the main takeaway is that the hook detected 3 major vulnerabilities: the possibility of SQL injection, the fact that debug mode is enabled, and that shell equals true in subprocess, which enables shell injection. All very important information to bear in mind. So we created and tested a security vulnerability detection hook. It intercepts all write to file operations before they execute, and it scans for 15 incredibly common security vulnerabilities on our behalf. And then we demonstrate right here that we blocked 3 vulnerabilities in our test file. So this hook is now active. Again, we can go to see our active hooks within this, and we can toggle it off if we want to, but why would you want to? It's security. And one should also note that in the enterprise version of Cline, we are able to enforce these hooks as well as prevent them from being toggled off as well.
Actually, I just want to add one little thing there. I think when we started this call, it was a dichotomy of security versus productivity. But with hooks, talk to your DevSecOps leaders, and it becomes, this is also a tool for them. So that can actually put the engineering side of the house on the same side as the DevOps or the security side of the house. This is a tool for both.
Absolutely. I found that the most beautiful scenarios when it comes to security are when the default path of deployment, aka the easiest path of deployment, is also the secure path of deployment. It just requires a little bit of thinking things through, for lack of better words, in order to enable that scenario. But you can hear angels singing in the background whenever that state is achieved for your organization, which is something that we all aspire for, right? A few more notes about hooks as well as enterprise use cases for them. They do enable enforcement patterns critical for regulated environments. For security controls, we detect secrets before they're committed. We prevent exposure of sensitive data. We restrict access to classified directories. And we block dangerous command executions. For compliance and audit, we create comprehensive change logs for SOC 2 or ISO 27001 certification. We track all operations for FedRAMP or RMF requirements. We validate STIG compliance, or we just maintain regulatory audit trails, key for compliance as well. For quality and operations, we can enforce code standards, we can require test coverage thresholds, we can mandate documentation updates, and we can even integrate with your existing SIEM or SOAR platforms. The key insight is that hooks run automatically with no developer friction, and these aren't suggestions, they are policy enforcement. And because they can call external systems, they integrate with your existing security infrastructure.